All right, you need your calculators for this. Test on Monday is all about our probability from chapter 3. So pretty much what you guys did on your quiz. Did I give you back those yet? Yeah. I did? Okay. Your quiz from earlier this week, that's the kind of stuff that's going to be on your test on Monday. So we're going to go through those problems today. I think it's 1 through 13 in your study guide. And then you're going to take that on Monday. Tuesday, we'll go through the rest of the study guide, and you'll take the chapter 4 part on Wednesday next week. All right, but you can use your graphing calculators for both parts. So it says a student must choose from 7 classes to take at 8 a.m., 4 classes to take at 9 a.m., 3 classes to take at 10 a.m. How many ways can we arrange this schedule? What do you do? This is where you talk. We interact with each other. That's how this works. Number of choices, right? How many choices do we have for the first time slot? 7. How many choices do we have for the second time slot? 4. Third time slot? 3. That's it. Multiply them together. 7 times 4 times 3. 84 ways to arrange the schedule. Okay? Your travel agent is arranging your honeymoon. You have several choices to make. You are staying in 2 different hotels, taking 3 day tours, and eating dinner at 5 restaurants. There are 5 hotels, 7 day tours, and 11 restaurants to choose from. How many different combinations can you choose from? Order is important for reservations. All right, so what are the 3 things we're choosing? The first thing we're choosing is hotel, so I was using H for that. The next thing we're choosing is the tours, and the last thing is restaurants. Okay, so let's start with the hotel. We're going to pick 2 different hotels, and we have 7 to choose from. So how do I do that when order is important? Seven, choose 2. Is it going to be a P or a C? It will be a P if order is important. So 7 permutations of 2. Okay. All right. 3 day tours, and I have 7 to choose from. Oh, wait, did I do that wrong? There are 5 hotels, not 7. I read that wrong. There we go. 5, choose 2. All right. 3 day tours, and there are 7 to choose from. There we go. What am I going to do? 7, P, 3. 7, choose 3. Order is important. And then restaurants. How many restaurants do I have to choose from? 11. And how many am I picking? 5. And then this is where you'd want your graphing calculator probably. If you don't remember how to do it in your graphing calculator, remember it's under math and then go over to probabilities, probably the easiest way to find it. You can also hit alpha window. That's a shortcut for your probability menu. You can use it on the test, yes. You will also have that formula sheet that you guys have on your green packet that has the table of values on the back of it. So if you wanted to do the calculation the long way with the factorials and stuff though, that formula will be available as well. All right, so 5, choose 2 gives me, I'm just going to write it out, 20. 7, choose 3 gives me 210. And 11, choose 5. There's a lot of choices there. 5, 5, 4, 4, 0. Times 210 times 20. You can type it all in at once if you want. Final answer 2, 3, 2, 8, 4, 8, 0, 0, 0. About 233 million options. Okay. Questions on number 2? Cool. All right, number 3, we're using the table to answer the questions. First question, the probability that a randomly selected degree will be in either business or psychology. Now, before I start putting those pieces of information together, what is something important that is missing in this table? You need to do the total first. All right, so let's go ahead and add those up. 361, 181, 178, 114, and 1006, 1840. Okay, so the probability that a degree will be in business or psychology. So how many people are in business? 361. So the probability of selecting a business degree is 361 out of 1840. Psychology would be 114 out of 1840. And then when we have an or statement, we add, that's the addition property. You also have to consider that sometimes with these or statements, there could be an overlap. There could be events that are not mutually exclusive. Is it possible to have these events overlap? Could a business major also be a psychology major based on the information we have? No, so we don't have to worry about here subtracting the intersection. We're assuming that they are mutually exclusive. So my numerator, 361 plus 114, I get 475 on top, 1840 on the bottom. And then like you've been doing in your Math Excel, let's turn this into a decimal. And let's just say 3 decimal places is going to be our standard rounding place here. So 0.258. Next part, find the probability that a degree will not be in health. So there's 2 ways to do this problem. You can add up all the degrees that are not health and divide by 1840. Or, kind of a shortcut to that, is you could do the complement of health, which is 1 minus the probability of selecting a health major. It's just the exact opposite group. So health major was 181 over 1840. So the complement of that is every other major. 181 over 1840 gives me 0.098. Take that away from 1, I get 0.902, which again is the same answer you'll get if you add up all the other majors and divide by 1840, or the other degrees. Questions on 3? Okay. Number 4, a basic Ohio license plate has 3 letters, 4 digits. Let's say that there is a restriction that doesn't allow an A for the first letter and doesn't allow a Z for the last letter. Also, let's say that you can repeat letters, but not the digits, and all digits have to be even numbers. How many different license plates can there be? All right, so I have 3 letters, letter, 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 and I have 4 digits. Digit, 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 digit. All right, and again, we're going to look at how many choices we have for each slot. How many choices do I have for the first letter? 25, because it can't be an A. How many choices do I have for the last letter? Well, 25, but also my letters cannot repeat. Right? Oh, you can repeat letters. It's just the digits we can't repeat. So it'd be 25 again. You're good. And then how many choices do I have for the middle letter? 26. Okay. If the letters couldn't repeat, I would put a 24 there, and I'd put a 24. And then I would put another 24. Digits, how many digits are even? We have 10 digits total. How many of those are even numbers? 5. 5 digits, 0 included. 0 is included as an even number. So I cannot repeat the digits. So how many choices do I have for the first digit? 5. The next one? The next one? 3, 2. Multiply them together. 25 times 25 times 26. 5 times 4 times 3 times 2. 1,950,000 different license plates. Okay. All right, a card is selected at random from a deck of 52 cards. Find the probability that the card is a club or a 7. How many clubs do I have in the deck? 13. So the probability of selecting a club is 13 out of 52. Remember when we use the word or, we're adding. It's the addition property. Plus, how many 7s are in the deck?
4
out of 52. Is there any overlap between the two? Yes, there is one card that is a 7 of clubs. So minus 1 over 52. We always subtract the overlap. So that's a 17 minus 1, 16 out of 52, which is a probability of 0.308. So find the probability that we get a face card given that it is a heart. Whatever you are given, we are assuming that that is the total group. So we know it's a heart. How many hearts are there? There are 13. So we know it's a heart, which means we are no longer looking at the entire deck of 52. We're just looking at the 13 hearts. And I want to know what the probability out of those hearts that I get a face card. So face cards are ones that have faces on it. So jacks, queens, and kings. How many jack, queen, and kings of hearts are there?
1
There's one of each. 3. 3 out of 13. 0.231. Questions on 5. All right. Number 6. In a sample of 28 puppies, 18 of them are labs, the rest are chihuahuas. If you grab 3 puppies, don't grab puppies, pick them up nicely. If you pick up 3 puppies at random without replacement, what is the probability that all 3 are labs? Okay, so let's find the probability, first of all, that our first selection is a lab. So how many labs do I have? 18 out of how many total? 28. Now we are not replacing. And when we talk about things happening consecutively, that's an and statement. And when we're talking about an and statement, that's our multiplication property. We are multiplying all of these together. So 18 out of 28 for the first puppy. What's the probability I get a lab on the second puppy? 17 out of 27. And the third puppy? 16 out of 26. So 18 out of 28, 17 out of 27, 16 out of 26, and I get 0.249. What is the probability that none of them are labs? So none of them are labs means all of them are what? Chihuahuas. All right, so how many chihuahuas can I pick on the first selection? 10 out of 28. And after that, 9 out of 27. Again, because we're not replacing, and 8 out of 26. Multiply them together. I get 0.037. I give it 3 decimal places. Okay, the last part of this question, what is the probability that at least one of them is a lab? Now, if you try to calculate that at face value, that can get a little complicated, right? 1 is a lab, 2 is a lab, 3 is a lab, and then you have to add all those different options together. We didn't do that back in chapter 3. Back in chapter 3, we talked about at least 1 is the complement of what? Yes, that's the easiest way to do this problem. It's the complement of none. And no labs was something we already calculated, so we might as well use it. It's 1 minus, when we're doing our complement, no labs, 0.037. So every other selection will have at least 1 lab in it, 1 or 2 or 3. 1 minus 0.037, 0.963 is your probability. All right, backside. "62 actors showed up for audition parts for a movie about the Beatles. How many ways can the director cast the roles of John, Paul, Ringo, and George?" There are two different ways to do this problem. You can do it by hand, making a selection for each actor, or you can do it by making choices. So many, choose so many. Does order matter in this problem? Let's say I have 4 people. Person A is John, person B is Paul, person C is Ringo, person D is George. Is that different than person B being John and person C being Ringo? That's different, isn't it? If you have a certain role that you're playing, that's important, what role you're being assigned. So order does matter here. If order matters, is it permutations or combinations? It's permutations. So the easiest way to do it is 62 permutations of 4. 62 choose 4. You could also just do, which is the formula that this ends up simpling to, 62 times 61 times 60 times 59. If you have that on your paper, that will give you the same answer. Which is a lot. 133888280. About 13 million. Okay, so again, you could also do this. Choices for each acting role. Okay? Questions on that? Okay. An employer must hire 2 people from a list of 13 applicants to be computer techs. In how many ways can the employer choose to hire the 2 people? Does order matter? Order does not matter here, because let's say Bob and John are getting jobs, and if they're selected, whether Bob is selected first and John is selected second, or vice versa, they both still have the exact same positions. Right? Doesn't matter who's hired first, who's hired second. They get the same job at the end of the day. So this is a combination. Order doesn't matter because they're getting assigned to exactly the same thing. Whereas in the last problem, there were 4 different acting roles, so order did matter. So combination, 13, choose 2. I get 78. Okay. Moving on. Evaluating, this is just simplifying in your calculator. Remember that factorial symbol is, again, under that math probability menu. So you probably can type this all in at once in your calculator. Just hit alpha, y equals enter to get that fraction set up first. And then just take your time with it. Nine, 6, 5, 7, 6, 4, 8. You could also recognize on this one, this is the formula for combinations. 67, choose 5, which would give you the same answer if you wanted to do it that way. If we don't have the extra 5 factorial there, that's where it would be a permutation of 67, choose 5. That was the difference between the 2 formulas. The combination divided out a little bit more at the end because certain groups counted the same. So we didn't have as many ways to organize things. All right, number 10. A team has 53 players. There are 28 that are on the offensive roster, 25 that are on the defensive roster. Suppose 7 are chosen at random to be drug tested. What is the probability that there are exactly 2 offensive players and 5 defensive players? Do you guys remember we did a problem or a couple problems like this? It had to do with like corn kernels, like bad radioactive kernels being selected. So if you look back at your notes, I can't remember what section that was. That's what this problem is going to look like. We're going to have different ways to combine things. We're going to have first the total ways that we can choose. How many people are we choosing? 7 players in general. So how many players do I have total? 53, and they're choosing 7. Order, does it matter here or not if we're just picking a group? Order does not matter. So it's a C. Then we're going to look at the 2 different more specific selections we're making. Offensive players and defensive players. Both of those, again, order will not matter. We're just picking a group. All right, so how many total offensive players are there? 28. And how many do we want to choose? 2. And how many defensive players are there? 25. And how many of those are we picking? 5. That's it. Okay. So on top, it's calculating the different ways that we can pick 2 and 5. On the bottom, it's calculating the total. We're going to go ahead and divide those, and that'll give us our probability. So again, this will take a minute to type in. Again, alpha y equals enter to start here could help you get that fraction set up. And 53, choose 7. 0.130. I get when I type that in. Questions on that one? Okay. Miss America has 50 contestants, and at the end of the first day, they announced that 5 are going to make the final round. How many different lists of these 5 ladies can be made, considering that order is not important? Am I using a P or a C? C. 50, choose 5. That's it. About 2 million ways to do it. One thing I noticed on the quiz is a few different times I had people calculating probability when the question wasn't asking for probability. If it's a probability question, you're going to divide something and you're going to get a decimal. If a problem says how many ways can something happen, you should not have a decimal answer. Okay, that's where you're pretty much using just the denominator. You don't have to worry about what the numerators are, or vice versa, depending on, again, what it's asking. All right, now the next problem kind of goes along with that. What is the probability that 2 states that start with an A will be in the top group? All right, so how many states start with A? 50 states do not start with A. All right, let's see if we get them all. Alaska, Alabama, Arkansas, Arizona. Atlanta's not a state. I've got 4. Am I missing anybody? Does that sound right? 4? Okay. So let's zoom. 4 states start with A. All right. So this is a probability. And in the last problem, we already figured out our denominator was 50, choose 5. That was all the different lists that can be made. Okay. We want 2 states to start with A out of how many total? Let's start with A. 4. So this is our A group. It's kind of like the football problem. 4, choose 2, or it doesn't matter. It can be Alabama and Alaska or Alaska and Alabama. same choice. And then how many ways are there for me to pick all the other spots? How many ladies are left? There are 46 ladies left. And how many more spots do we have on the list? Well, we've already picked 2 A's. So I have 3 spots on the list. When you guys do problems like this, the totals on the left should add up to the total on the left in the denominator. And the totals on the right should add up to the total on the right in the denominator, if you're doing it right. Okay, so that can help if you're not sure how to set up one or both of them. All right, so again, take a second, type it in. I'm just going to bring up on my calculator what I typed in a few minutes ago. So now it's 4 choose 2, 46 choose 3, and 50 choose 5. And I get, my calculator gave me a fraction when I did it, 99 over 2303, but I'm going to go ahead and divide that. 0.043 is the probability. Is that an unusual probability? Yeah. Just adding an extra little note on that. Let's just mark that down. Why not? Why is it unusual? Less than 0.05 was what we used for probability. Okay, what is the probability that Miss Ohio will be in the top group? So this is worded a little simpler than the last problem, but it is the same setup. So we've got 50 choose 5. And the first selection will be Miss Ohio. And the second selection or selections will not be Miss Ohio. So how many Miss Ohios are there? 1. And how many ways are there to choose Miss Ohio? There's 1. So it's 1 choose 1, which is just 1. You could put a 1 there. Not Ohio. How many ladies are not Ohio? 49. And how many more spots on the top 5 list are there? 4. Okay, again, the numbers on the left should all add up to each other. The numbers on the right should all add up to each other. So type it in. 1 choose 1. 49 choose 4. 50 choose 5. And the answer is exactly 0.1. Miss Ohio has a 1 in 10 chance of being in the top 5. Okay. Questions on 12? No more practice with that? All right, last but not least, number 13. We're talking about distinguishable ways here. That is important. How many distinguishable ways can books be placed on a shelf given that 3 are pre-calc books, 5 are Algebra 2 books, and 4 are AP Calc books? First of all, how many books are there? There are 12 books. So let's say all 12 books were different. If all 12 books were different, how many ways could I order them on the shelf? 12 factorial. 12 times 11 times 10 times 9, etc., etc. But we have certain books that are exactly the same. I have, what do I have? 3 pre-calc books that look exactly the same. So what do I divide by to adjust for all those that will be in the same setup? 3 factorial for the pre-calc books, 5 factorial for the Algebra 2 books, and I have 4 of the same AP Calc books. All right, so 12 factorial, again, find that factorial symbol on your math probability menu, and then divide it by all those on the bottom. When I do problems like this, honestly, in my calculator, I don't even like finding that exclamation point symbol, so I'll just type in what it actually means on the bottom. 5 times 4 times 3 times 2. takes me a long time to get to it every time, I feel like, so I get impatient. 27,720. Different ways to arrange those 3 types of books. Okay. How many distinguishable words, and words is in air quotes there because they might not be words that are actually in the dictionary, can you make by scrambling the letters in MacDonald? How many letters are in my last name? There are 9. 9 factorial. How many M's are there? Well, actually, which letters repeat? The A's repeat. The D's repeat. Is that it? So what am I going to divide by? 2 factorial, 2 factorial. So 9 factorial divided by really just 2 times 2, divided by 4. 90,720. All right. That's it. Test on Monday. All right. So this weekend, if you want, well, first of all, not a choice is you need to finish your 4 homework. 4.1 and 4.2 are doing Math Excel by Sunday night. Also, just like last time, I made an optional practice test and put it online for you guys. I did not print it this time, but it is online. If you go to the test review folder in Polaris, there's a blank version of it, and then there's a version that has the solutions. I labeled on it which problems come from which chapter. So if this weekend you just wanted to practice the chapter 3 stuff, you can do that, check your answers. Those of you that were asking, how can I study? That is the best way to study. Print out that practice test or write the problems down. Give yourself an hour to do them like you would on test day, and then check your answers. And if you're getting problems wrong, go to your textbook, look at your worksheets we did in class together, and try some more like it. Okay? I will be here in the morning on Monday if you have any extra questions before the test. All right, cell phone lotto. So cell phone lotto, we were doing a spinner in some of my other classes, and they thought that was fun. You guys want to do the spinner? They also thought I was cheating with my graphing calculator. I'm not going to take that personally. All right, ready? This is much more exciting. Well, it's slow, but it's being really slow right now. There it goes. There it goes. Come on. 10. Nobody won. But look, there was. Oh, somebody did one? Oh, there's a. Oh, yeah. Oh, hold on. Doesn't that encourage you to put your phone in there? There's like a penny and there's Noli. I literally just recorded it this morning. I'm going to post it. So I'm going to I got my